All right, so I'm going to create this video and hopefully it helps. Okay, so let me clear this. This is about solving equations that relate to log functions. So here's an example. Okay, so if you have this, something as simple as this, and I'm going to go through several examples so you can see the difference. Okay. And they ask you to solve for x, right? So what do you do with these things? The first thing you notice is that on the left-hand side, there's a single log. And also on the right-hand side is a single log. This is probably one of the easiest cases. And the property that we're going to use is this. It says, if this is a property, log of x is equals to log of y, then this implies that this argument must be equals to this other argument. And then you solve for x or whatever. But in this case, in the example that I'm doing now, the argument is 2x plus 1 should equals to the other argument. So now all I have to do is solve for x. So I'm going to move this x over. And this 1, I'm going to move it over to the other side. In fact, let me make this a plus, okay? So here you get x equals to 3. And then you're supposed to check the answer into the original equation, okay? So this is probably the easiest cases, but I want to do another case in which you have to do a little bit of work, okay? So here's the example. We have log of x plus 5 equals to 1 minus log of x plus 2. And here the case, in this example, the base is 5. Oops. Doesn't look like 5, but that's a 5. Okay. Now, let me go back to the example that I just finished. In this case, notice that there was no base written. In that case, the base is understood to be 10 automatically, but they're not going to write that, okay? And also, in this example that I did here, the first one, the base did not play a role whatsoever, okay? All right, so let's see what happens here. So now, what I'm going to do, notice the difference. On the left-hand side, I have a single log, and on the right-hand side, I have two terms. I have a number, and I have a log. To make this the easiest way possible, I'm going to move this log to the left-hand side. So now this is going to look like this now. This is a minus. When I move it over, it becomes a plus. The signs inside the argument do not change. Okay? Now, don't forget here I have a 1. So that's a 1. All right. What do I do with these two logs here? Well, the rule says that log of x plus log of y equals to the product, log of the product of the two. That's what that means. Okay, so I want you to keep in mind that none of these problems can be done if you don't use the properties. The properties are just tools that will allow you to get the job done. Okay, so now I'm going to erase that because I need the space. Okay, but that's what I'm going to do. I'm going to multiply this argument. I'm going to multiply this argument and this argument, and I'm going to have just one log here. Okay, so in fact, let me write it just below so that you know what I'm talking about. So I'm going to have log, and then I'm going to have x plus 6 times x plus 2 equals to 1. Okay? Do not forget that the base is 5. I wrote it here, now it's here. Okay, so now this is where I am. Okay, this is where I am. So now, before I do anything else, there's another property. I guess this will be B, and C is this. Log of x base A equals to a number, let's call it y. It's the same thing as writing y. Hold on, I made a mistake. It's equals as writing as A, the exponent of y equals x. Those two things are the same. One is in exponential form, which is this, and this one is in log form. So I'm going to do that in this example. Once I reach this far, I'm going to do exactly that. Okay? So I'm going to move this to the other side. Actually, I'm going to erase some of this stuff, so maybe that you don't need this. You can always watch the video again. So what does it look like now? So if I apply this property here, this one, this now would be 5 raised to the first power equals to, then I have this product, which I will expand in a minute. Okay? No more log, it's gone. Okay, it's gone. I'm going to continue to erase this, I don't need it. And now all you have to do is solve for x. Just give me 1 second. So there it is. So here I have a 5. I'm going to FOIL this. And I'm going to have x squared plus 2x plus 6x plus 12. Okay? I combine like terms. And also I'm going to move this guy to the other side. I apologize for the noise. I hear my wife speaking on the phone. So this is 12 minus 5. So what do I have now? Okay, what do I have now? Again, I keep erasing this stuff because I'm running out of room. Let's see what this looks like. So what I'm going to need to factor is this x squared plus 8x, and I'm going to have a 7 plus 7. Okay, that's what I need to factor. All right, that's what I need to factor. All right, so how do I factor this thing? Notice how early on in the semester there were some exercises where you were required to factor. Well, we're not asking you to factor, in a particular specific problems about factoring, but factoring is basically throughout the entire course. So this is why you need to know how to factor. This is going to be x. Factors of 7 is 7 and 1. All the terms are plus, so I put a plus, and that will work. 7 times 1 is 7. 7 plus 1 gives you 8. You set m equals to 0, and you solve for x. Notice that we have -8, -7, and -1. At this point, you cannot claim victory. You cannot say at that moment that those are your solutions. You cannot do that. You need to evaluate each of the terms. I'm going to do -7 first. Okay? I'm going to do -7 first. If after I evaluate the logs at -7 and I end up with a negative argument, then we cannot use that value of x. So here, I'm going to evaluate -7. So log of -7 plus 6. That will be equals to log of -1. At this very moment, stop and throw this answer away. It's not going to work. In fact, you can check this in your calculator and you will see that if you put log of -1, the calculator will say undefined. Okay, it doesn't exist. All right, so let's do the same for -1. Okay, I'm going to do the same for -1. So when I do -1, I'm going to have log of -1 plus 6 equals to 1 minus log of -1 plus 2. What is that equals to? Well, this will be equals to log of 5. Okay. And this, by the way, will be log of 1. Okay. This will be log of 1. Log of 1. And by the way, log of 1 is 0. And what do you have left? You have left log of 5 equals 1. Well, one thing that I forgot to write is the base. And that is true. Log of 5 base 1, it is equals to 1. Okay? You can check this in your calculators. If you put log of 5 divided by log of 5, it gives you 1. This is how you check your answer in the calculator. You put log of 5 divided by log of the base. In this case, it's also 5, which gives you 1. That little trick is called the change of base theorem. Okay, which basically says that if you have log of A base B, this is the same thing as log of A divided by log of B. And they will give you some number. Use a calculator for that. Feel free to do that. You need to learn the properties of logs, all of them. You're not going to be allowed to have those during the test, so memorize them, practice them. And one way that you can do that is by rewriting them. But the key is knowing when and how to use them. Okay? So I hope this helped. And by the way, the answer to this problem then would be equals to x equals -1. And you might say, well, what happens to the -7? I already told you what happened. It doesn't work. Okay? So as you can see, when you do find these two answers, do not say yet that those are your answers until you check them. Do not fall into that trap. Okay, so I hope this you find this helpful, and I'm going to stop here now. Bye bye.